Today we are going to record another session on ELF tutorials. This session will be on lottery game contract. Lottery game contract is a moderately complex contract and it demonstrates the use of state variables, user interactions, and random number generation to create a basic lottery game. The purpose is to introduce you with the more advanced concepts such as state management, event handling, and randomization in a smart contract. This tutorial will contain 4 steps. The first step is setting up the development environment. The next step is developing the smart contract. And the next step is deploying the smart contract. And the last and final step is to interact with the deployed smart contract. In the first step, we will set up our development environment in our local system. So to install the dependencies which are required for this, we will follow the first step. You should have basic knowledge of terminal commands. Then you should have an IDE installed. If you don't have an IDE installed, then you can install VS Code because I'm going to use VS Code in my system. You can click on this link and then install according to your operating system. In the next step, we will install the required packages. The first is the .NET 6 SDK. If you haven't installed .NET 6 SDK yet, then click on this link and install based on your operating system. I will check whether it is installed on my system or not. I will check using the .NET version command. You can verify whether the .NET is installed successfully or not on your system using the .NET version command. As I can see, .NET version is showing as 6. It means it is already installed on my system. In the next step, we will install the ELF contract templates. ELF contract templates contains the predefined templates for the ease of development of the smart contract on the ELF blockchain. So first, we will copy this first command to install the ELF contract templates. We will copy this command, we will paste this command in the terminal, and we will see the installation process. It is showing that it is already installed on my system, but if you install it for the first time, it will install the ELF contract templates on your system. In the next step, we will install the ELF deploy tool using the .NET tool. So we will copy the next command and then we will paste this command in our terminal, and then it is showing that ELF deploy is again already installed on my system. It will show the successful installation process for you if you haven't installed ELF deploy tool yet. It will also show you the path, so you need to export the path once you install the ELF deploy. In the next step, we need to install Node.js and Yarn. If you haven't installed Node.js, you can click on this link and you can download Node.js for your operating system and then install it on your system. I will check whether I have installed Node.js or Node on my system. I will check the Node version using node-v command. It is showing that Node is already installed on my system with version 20. In the next step, I will check whether Yarn is installed on my system or not. And if it is not, then I can use the next command npm install with global flag and Yarn. We can check whether Yarn is already installed on my system or not using the yarn-v command. As it is showing that it is already installed, and you can check after the successful installation, you can verify whether the Node and Yarn are successfully installed. Then after that, we will install the ELF command using the npm package. So we will copy the next command and then we will paste that in the terminal. It is asking for the sudo privileges because of the global flag, and same happened with the Yarn. The Yarn also contains the global flag. It shows EXS issue while installing. Then you can use sudo privileges and then enter the system password. I will enter the system password by entering the next command to install ELF command. It will install ELF command on my system. In the next step, we will develop the smart contract. At this step, we have installed Node.js in Yarn. We have installed ELF contract templates and ELF deploy tool along with ELF command. As we can see, the installation process is ongoing. Once it finishes, it will install ELF command on my system. Till the installation process complete, let's talk about developing the smart contract. In the next step, we are going to develop the smart contract where we will create a new directory called mkdir lottery game and using the mkdir command. And then we will change to that directory and then we will create a new project called lottery game inside that directory. So as I can see, the ELF command installation process has completed. Now I will do the creation of the repository in the aelf tutorials folder. So I will change to that folder first using the cd command. Then I will create a new directory using the mkdir command called lottery game. Then I will change to that directory using cd command, and then I will create a new elf project using .NET new elf command. We paste this inside our terminal and it will create a new project. It will show that the contract was created successfully. You can check by using the ls command. It will show source and test folders. In the next step, we will open this project in our IDE, that is VS Code. So we will open the folder as it was inside desktop, help tutorials. There is a lottery game folder. I will open this inside the VS Code. So here we can see there are certain files which has been generated in the source folder and inside the test folder. In the next step, as we have the template for the lottery game project, we will customize the template to incorporate our own logic. Let's start by implementing the methods to provide basic functionalities and for updating and reading a message stored persistently in the contract state. First, we will change the folder to the source folder. We'll open the terminal inside the VS Code and we will go to source folder. In the next step, we will move the proto of hello world contract.proto file to lottery game contract.proto. You can do this by directly renaming the file from hello world contract.proto to lottery game contract.proto. So I will again go to the ID and open protobuf folder. Inside the contract folder, there is a hello world contract.proto file. I will rename this file with lottery game contract.proto. Now I can open this file and see the content. There is certain content inside this file. This proto file is used to define all the functions inside a smart contract. It is similar to a class or you can say abstract class or an interface where we define all the functions. Now we will copy the code of lottery game contract.proto and then we will paste it inside by selecting the existing code and we will paste the new code here. You need to delete the previous code and add the new code inside the proto file. This proto file explains certain functions or defines certain functions which are play, withdraw, deposit, transfer ownership, and functions like get play amount limit, get contract balance, and get owner. There are messages. Messages are called as events, and messages are called as outcome event, withdraw event, deposit event, and play amount limit messages. We will explain all these in the next steps. Now we will define the contract state. So we'll go to the IDE. Inside source folder, there is a file called lotterygamestate.cs. That is a C# file. We will copy the code and go to that file and select the existing code and we will paste the new code there and save the file. In the next step, we will define the reference state. So now we will create a new file that is a token contract.proto under the source and protobuf, and inside there is a reference folder. We might need to create a new folder called reference, and inside that we need to create a new file that is token contract.proto. So it is a reference folder we will create for the multi-token contract which we will be utilizing for the lottery game contract. So we'll again go to IDE. We will open source. Then inside source there is a protobuf folder. There is a reference folder as well. And inside you can see there is a acs12.proto file. We will create a new file inside reference. We have copied the name of the file, so we'll paste this here and then we will open this file. Now we'll copy the content of the token contract.proto from this tutorial and then we will paste this inside the file which we recently created. It's a long multi-token contract which defines how to create various type of tokens on ELF blockchain and how to interact with them. We'll scroll down where we have copied the whole code of the token contract.proto. Now we will navigate to the source folder and we will create a reference for this file. So now we will create a new file called contractReference.cs inside the source folder. So we will go to source folder. Inside source folder, we will create a new .cs file that is a contractReference.cs file. Now inside that we need to paste the content which is given inside the next code segment. We'll copy this and we will paste this inside the newly created file that is contractReferences.cs. In the next step, we will implement the lottery game smart contract. Now we will navigate to the lotterygame.cs file inside the source folder. So we will copy the content of lotterygame.cs file from this and then we will go to lottery game cs and we will select the existing code and we will paste the new code inside the lotterygame.cs file. Now let's understand the code of this smart contract. So this is our main smart contract which contains the namespace, the whole class inside, that is a lottery game class, And inside that, there are certain state variables like token contract address, that is a multi-token contract address which we will be using. This is the multi-token contract address on the test net on the aelf main chain. Now there is a token symbol, that is aelf, we will deal with, and then there is a minimum play amount and a maximum play amount that is defined as 0.01 aelf and 10 aelf. 8 zeros are used for decimals in aelf blockchain. There is a function to initialize the smart contract, that is a initialize function. In the next step, there is a function called play function, that is to play the lottery game where the logic is defined to play the lottery game. Then there is a withdraw function where the logic to withdraw the winnings is defined, where the asset should be defined. Asset is owner, which makes sure that only the owner can withdraw the amount of the winnings. In the next step, there is a function called deposit function, which allows the players to deposit to participate in the game. Then in the next step, there is another function, that is a transfer ownership function, where the ownership of the contract can be transferred to the other address. Next step is get play amount limit, that is to fetch the play amount limit of a particular game. Then in the next function, we can check the contract balance using the get contract balance function. In the next step, there is a function called get owner function, which returns the owner address, and whether we are a winner or not, we can check using this winner function. And these are two helper functions, that one is winner and one is asset is owner. These are similar to modifiers in the Solidity smart contracts. Now let's build our smart contract using the .NET command. So we will copy this command. As we are already inside the source folder, we will paste this command and build our smart contract. So it will simply compile our smart contract and build it based on the contract reference files which we have provided, that is a token contract.proto, and then we created a reference file for that, contract references.cs, and then we provided the main logic inside lotterygame.cs file. As we can see, the build was successful with a warning. You can ignore the warning in this step. In the next step, we will deploy our smart contract. That is our third step of this tutorial. For this, we need to use the aelf command, where using the aelf command, we need to create an account. So to deploy the smart contracts, we always need to create an account where we need to have certain balance of the native token to deploy the smart contract, because smart contract deployment is again a transaction. So we'll copy this command to create the account on the blockchain. Aelf command will create a new account for the user. If you face this issue of unsupported digital envelope routines, you can switch your node version. So as you can see in this terminal, the node version is not used as 20. So I will use NVM. You can install NVM using npm command. So I will see the list using NVM. And here I can see we have a 20 version also installed, but it is using 18. So I will just use nvm use command, nvm use v20, and this is the version which we will be using. So I have switched to the Node 20 version. In the next step, we will create the account using the aelf command create, and it will create an account where it will return mnemonic, the private key, public key, and the address. Private key and public key are the main components of an account, but to provide it in a simple way, we create mnemonic and addresses. Address is a representation of public key, and mnemonic is a representation of the private key, which is in the simplest format. And then we will save this information in a file by providing the yes option, and we'll have to enter a password to save this information in a file, and we'll have to confirm our password. It will save all this information inside a JSON file inside our local system. It means we have created the account to deploy the smart contract. In the next step, we will export our wallet address and wallet password as well. So we'll have to set up these environment variables. So we'll use the export command, where we will use wallet address equals to the address which was generated in the last step, and we will copy this and we will paste this in this step. So we will export another environment variable, that is export wallet password, which we set for a file which we created to store the wallet information which we created in the last step. So for me, it was Mohit at 123. For you, the password you have chosen, you have to enter that password here, and you need to set this environment variable. Once you set both these environment variables, you can get some aelf tokens to deploy the smart contract from the aelf faucet. As we have already exported wallet password and the wallet address, now we will copy the next curl command to get some tokens from the aelf faucet. Copy this command and go to the terminal again, and we'll paste this command. Once we paste this command, it will return is success true or false. If it returns is success true, it means it has given the tokens to your account. Now, how to verify that? We will check the balance in the next step. As we can see, this is the multi-token contract address which we also used inside our smart contract. So we'll copy this command to check the balance of the tokens which we got from the faucet. So we'll copy this command, we'll paste inside the terminal. It will ask for which token you want to see the balance. So it is the aelf token, aelf is the symbol, and then it will ask for the owner. Owner is the address which you created using the aelf command create. So we'll paste this address here, and then you can see the balance is aelf tokens along with 8 decimals, or you can say 8 extra zeros. At this step, we have successfully created an account and we have successfully got some test tokens to deploy our smart contract. In the next step, we will deploy our smart contract. First, to deploy the smart contract, we need to set another environment variable, that is a contract path. Contract path is the path of the .dll.patched file inside the bin folder which was created as a result of .NET build command. So here inside source folder, you will see there is a folder called bin/debug/net 6.0. There you will see a file with .dll.patched extension. So you need to copy the path of this file and you need to export a new environment variable, that is contract path, contract_path equals to the path of this TLL test file. Once we do that, we can deploy the smart contract using the next command. We'll copy the next command to deploy our smart contract, and we will paste this command inside our terminal, and we will deploy the smart contract on our testnet. This is the URL of our testnet, and press enter. Once we do that, it is showing that command not found. So we'll again go back to our local environment setup. We'll copy this command. So first we need to uninstall the existing files of aelf deploy which might be on our system. So first we will use .NET tool to uninstall the aelf deploy. It was successfully uninstalled. Now we will install aelf deploy. It will install the aelf deploy tool using the .NET tool command. And here you can see it is asking us to export a path. So we need to copy this environment variable and we need to paste it inside our terminal to export the path. Paste this here, and now we will see again whether it is installed successfully or not using the aelf deploy command to deploy our smart contract. As you can see, the deployment process has started. It means the aelf deploy was successfully installed. Now, as the deployment process is going on, let me explain what happens in the deployment. So in the deployment process, we need to create an account as smart contract deployment, and then this account is created with public keys and private keys. There, mnemonic and addresses are derived version of private keys and the public key. Mnemonic is a simple form of the private key and address is a simple form or the short form of the public key. In the next step, we have used faucet. Faucet is required to simply get some tokens to deploy the smart contract. As we interact with the blockchain, so interaction with blockchain requires some transaction cost. So for that, we need some tokens. And as ELF is the native token of ELF blockchain, so we simply claim those tokens from the faucet using this next command. In the next command, we check the balance whether we got the token successfully or not. And in the next step, try deploying the smart contract. As you can see, the smart contract deployment process has finished and we can see it has returned an address. So this is the smart contract address which we deployed now. So we deployed the lottery game contract and this is the address of that contract. In the next step, we will interact with the smart contract. But before interacting, we will export another environment variable, that is a contract address, which was recently generated from the deployment process. So we will copy that address and we will paste that address inside that command. Once that finishes, then we will move on to the next step. Now in this step, we will interact with our deployed smart contract. So first we will approve the smart contract spending because we will be dealing with the aelf tokens for the lottery game. We'll have to deposit. So we will use the multi-token contract address to send. As it is a send command, we will use the approve function inside that. So we'll copy this command, we'll paste this command inside terminal, which will approve the spending. So now you can decide the spender. So spender should be the address of the contract, because the contract will spend on your behalf, and then it will ask for symbol and the amount which you are allowing the contract to spend on your behalf. So we'll copy again the contract address which we generated in the last step, and then we will paste this here as a spender, and then we will provide the symbol, that is aelf, and then we will provide the number of tokens which this contract can spend on your behalf. Let's say it is 5 elf tokens, but not 5. We need to add extra 8 zeros because elf has 8 decimal places. So we'll provide this. We'll check the zeros. These are 7 zeros. We'll add one more zero. So it means we have given access to spend 5 tokens to the smart contract. Now, as you can see, the call was successful. In the next step, we will initialize our lottery game contract. Whenever you deal with ELF blockchain smart contract, the first step you need to do is you need to initialize the smart contract. Well, copy the next command, and then we will paste this inside the terminal to initialize the smart contract. As it is initializing the smart contract using the initialize function, it was again successful. Then we will move to the next step. We will deposit the funds inside the lottery game contract so that we can use for the lottery game. So we will use the deposit function, and we will call the next command for the deposit function of the lottery game smart contract. Paste this, and it will ask for the value. So how much you want to deposit. So let's say we want to deposit 1 ELF token. Again, don't forget to add extra 8 zeros, which are the decimal places of ELF tokens. So now we have provided 1 ELF token to be spent on our behalf, and it was again successful. In the next step, we will play the lottery game. So we'll again copy the next command, and then we will call the play function inside this command, and it will play on our behalf. Now we will press enter. It will ask for the required parameter. So now we will check. We need to pass the required parameters. As for the play, we need to provide certain things. So let's check. This is the play command. So we need to provide the value. Let's say you want to play with 1 ELF token, so you need to provide 1 ELF token. Now it was again successful. Now, as you have played the lottery game, we can check the balance again using this command, using the get balance command, where we'll have to provide the symbol and the owner. So the symbol is aelf, and owner is the contract address. So we will check the contract address. We can check the balance of the owner as well. So it means we didn't win anything as the balance is 0. We can again check the balance of the creator or the player. So this was the address of the player. So we will call the get balance command. Here we'll enter the symbol and check the balance of this. So here you can see the balance has reduced according to this, and then it has given certain tokens for the game. And we have played this game. So we have successfully concluded this tutorial. That was a ELF lottery game contract tutorial in which we followed 4 steps. Initially, we set up our development environment. Then we developed our smart contract, where we created the token contract proto file and the reference for that. And then we developed the logic of our smart contract in the lottery game.cs file. And then we built our smart contract using .NET Build. The next step, we deployed our smart contract by creating an account on ELF blockchain, and then by using the ELF deploy command, we interacted with the functions of the smart contract. Those are deposit, play, and other functions. We had to initialize the smart contract before using other functions. Congratulations, you have completed another tutorial on ELF blockchain. Stay tuned. Thank you.